Today we look at chemistry. The question is based on vapor density. Let's look at the question without wasting time. If 11 grams of a gas occupies 5.6 dm³ at STP, calculate its vapor density. 1 mole of the gas occupies 22.4 dm³ at STP. We have the option. Solution. We'll start from here. 1 mole of the gas equals to 22.4 dm³. That is at STP. Standard temperature pressure. Now in the question, if 11 grams of the gas occupies 5.6 dm³ at STP, now chemistry calculations are very simple. They are very, very simple, but we have to follow rules. Let's put dm³, this volume, under volume. We have 5.6 dm³ at STP. So we'll look at number of mole here, or no, S mole. So we are balancing it. So we'll cross multiply. If you cross multiply, you have 5.6 times 1, and we have 22.4 times x. So we have 22.4x equals to 5.6 times 1. We'll see how 5.6. 5.6. So cross multiply 22.4 here. And cross multiply divided by the coefficient. 20.4 comes to 22.4. So when you divide this, you have x equals to 0.25 moles. Now we are not done because we are looking for the vapor density. We are looking for the vapor density according to the question. Let's move to the other side of the board. Now we are cutting the mole here. There is a popular formula. N equals to F all over ml. That is to say, amount in mole equals to mass all over molar mass. This is represent our mass. This is molar mass. Now, from the question, if 11 grams of a gas, this 11 grams represents mass. So we just got our number of mole here. Our number of mole is 0.25 equals to the mass in the question is 11 all over molar mass unknown. Here we cross multiply 2. If you cross multiply, we have 0.25 ml equals to 11. We divide by the coefficient here of the coefficient is 0.25. So 0.25 is 0.25. Both sides by 0.25 are divided by 0.25. So here we have, if you divide this, we have the molar mass here. We have 44. And molar mass is mentioned in grams per mole. And that's not where we are going exactly. Because the question says if 11 grams of a gas occupies 5.6 dm³ at STP, we have balanced it. We balance number of moles against the standard temperature pressure with the volume in the question. We got our number of mole here. So we use it here. Amount in mole equals mass per molar mass. So we use the number of mole we got here. And the mass in the question here. So we got mm here now. Now, we want to get our vapor density. The question says calculate its vapor density. So there is a formula for vapor density. Vapor density equals vapor density. We use relative molecular mass. This is what we are looking for now, vapor density. Relative molecular mass equals to 2 times vapor density. Now, we are looking for this. This relative molecular mass now, this mm will represent our relative molecular mass. 44 equals to 2 times Vd. This is vapor density we are looking for. If you multiply this, we have 2 Vd, but we are not going to do like that. To get our Vd, let's divide both sides by 2. So 2 cancels 2 here. So 2 here, 1, 2 here, 2, 2 here, 2. So Vd, which is our vapor density, equals to 22. So according to the question, our vapor density is 22. So option A is the answer. For those of you that have been subscribing during our chemistry class, thank you very much. I want to also tell you that this channel we now operate on TikTok. So the same name, Chemistry Made It Easy with that. Thank you for subscribing, for viewing, for commenting, and for sharing.